Okay, having seen how to plot an explicit curve, y equals f of x, both symbolically and numerically. So symbolically was with easy plot, and numerically was with plot. We're going to, in this short video, see how to define an implicitly defined curve, how to plot an implicitly defined curve, so a curve of the form fxy equals c, again via two commands, one symbolic, one numeric, and those commands will be EzcontourContour and contour. We'll also see that for the symbolic command, you can have your input be presented in the form of either a string or a symbolic variable. And we'll also see that EasyPlot itself will make a reappearance in implicit plotting. So let's suppose you wanted to make a plot of the following implicitly defined curve. So let's suppose we have x squared plus x minus y cubed plus y squared equals c. So we're going to do more than just actually plot a single curve. We're going to plot the level curves of the function x squared plus x minus y cubed plus y squared. And these commands, EzcontourContour and contour, will do that very nicely for us. So here's the first way to do it. So this is symbolically with string input. If you just type EzcontourContour and put the implicit function in quotes, of course. So x squared plus x minus y, cubed plus y squared. Quotes. That'll do it. MATLAB has a default setting where it chooses the rectangle over which to plot the level curves, and that rectangle is given by the one with endpoints minus 2 pi and 2 pi. So it's this rectangle. Incidentally, EasyPlot is the same. EasyPlot chooses minus 2 pi as the default rectangle unless you change it, and one can change it, and one can do that if you want to pick your own base here by again issuing the command EzcontourContour, putting in the same string arguments. So let me not repeat that. But now let's suppose we wanted to restrict. And so I will put in minus 1, 1, minus 2, 2. So if we enter that command, EzcontourContour will plot the level curves over the interval, over the rectangle where x goes from minus 1 to 1 and y goes from minus 2 to 2. Now alternatively, you can use symbolic input. So we do that. Not surprisingly, sims, but we have two variables here, x and y, and then we issue the command EzcontourContour, and same as before, but without the quotes. So again, let's just write dot 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 for the same expression, the polynomial x squared plus x minus y cubed plus y squared, and this time let's use a slightly different interval, which is one I will use in a moment when I issue the MATLAB command, minus 1.5, 2.5, minus 0.5, and 1.5. And in fact, looking back at my notes, this one is 1, not a 2. Okay. If instead you issue the same command but put an F after the EzcontourContour, so the same exact syntax, but put an F here and otherwise the same, then what happens is the level curves, the regions between two distinct level curves will be filled in with distinct colors. And you'll see that leads to some very nice diagrams. Okay, now suppose finally if we want to do a single level curve. So suppose we want to plot x squared plus x minus y cubed plus y squared equals 1. I don't want all level curves, I just want the single level curve where the right side is 1. In this case, it's better to revert back to EasyPlot, and you want just issue the command EasyPlot. Again, you put in the polynomial and minus 1. And that will do it. Now, of course, you should, as always, see the book Differential Equations with MATLAB for more information on these commands and various allied commands and other options that you can choose for augmenting and otherwise getting more information out of these commands, EzcontourContour and Contour. Now, we also have to describe the numerical plotting, and I'll do that in a moment. Now, to plot numerically, recall that for an explicit curve, we first have to set up a vector of values for the independent variable. Since we now have two variables, we have to set up a matrix of values in this case. That is done in MATLAB with the command meshgrid. Okay, so here is the syntax. X, Y, these are the two coordinates, is equal to meshgrid. Let's do minus 1.5, 0.1, oops, 0.1 colon 1.5. Those are the x coordinates, and the y coordinates I'll do from minus 0.5, again with step size 0.1, all the way out to 1.5. Semicolon. Don't forget the semicolon. Otherwise, MATLAB will print out the approximately 600 values here. Notice that the interval here is of length 3, with step size 0.1, so there's about 30 there, there's about 20 there, that's how we get 600. So you don't want to forget that semicolon. And then the second command in the sequence is contour, and that you have to put in x, y, and the polynomial, but of course in vector notation. So dot 2 plus x minus y cubed plus y squared. Can't forget the dots. And that will generate a numerical plot for your level curves. Okay, now let's turn to the actual MATLAB commands themselves. Okay, contour plots in MATLAB. First, symbolic plotting using EzcontourContour, and we'll do it first with string input. So here we go. Here's the command EzcontourContour of the polynomial in question. We run it. And there's the plots, the level curves of this polynomial x squared plus x minus y cubed plus y squared. Some interesting stuff going on here. So let's take a closer look. Notice that I specified now a rectangle, x minus 2 to 2, y minus 3 to 3. Let's run the section. And we've honed in a little bit on this interesting loop here. Those are what the level curves look like, at least in this rectangle that I've specified. Now let's take an even closer look. So here I've honed in even further and look at the coordinates. Those are similar to the coordinates I used in the previous 2 pages. In every case I'm doing a new figure, and now I'm also doing it symbolically. So I defined x and y to be symbolic variables, and notice the quotes are gone. Evaluate. And kind of an interesting picture. Obviously, it's not a single-valued function, right? Vertical lines here, and maybe even here cut the curve in more than one place. So these are interesting curves. Now, to illustrate, easy contour with an F at the end. F is for fill. Same command as before, but with an F. And what happens to the picture now? It fills in colors, distinct colors between the distinct regions in between the level curves. Nice picture. All right, now finally, what about a single level curve, which is often what we want to do? And as I said before, it's best in that case to actually revert back to easy plot, which can plot, for example, the level curve fxy equal 1 via the command easy plot fxy minus 1. Implicitly, it's equal to 0. So, to get the level curve of our polynomial equal 1, we just type easy plot x squared plus x minus y cubed plus y squared minus 1. And that will get us the level curve that we seek. There it is. Sort of unfortunate choice of green, but there's our level curve. Okay, let's now show how to do it numerically. As I said earlier, it's with mesh grid and contour. So we set up a new figure. There's our mesh grid. I've set up a rectangle between minus 1.5 and 1.5, minus 0.5 and 1.5 for the y variable. And then we issue the command contour xy in the polynomial in vector form. And what do we get? We get essentially the same picture as before. So either numerically or symbolically, we can see the contour levels, level curves of the polynomial x squared plus x minus y cubed plus y squared. In this case, I actually titled the curve because contour, unlike easy contour, doesn't give an automatic title to the plot. Okay, now you know how to plot both symbolically and numerically level curves and single curves defined implicitly. Actually, I just realized I forgot to show you how we can use numerical plotting to plot a single level curve or actually a collected set of level curves. So let's do that now. So to plot a single or selected set of level curves numerically, we use the command contour again. For example, if we wanted to plot the polynomial above, where it takes the values minus 1, 0, 1, or 2, we again issue the contour command, and we specify that range of values over here. And recall that the matrix of values is already set up via the mesh grid command. So let's run this. And there are the level curves through the values, 4 values selected, minus 1, 0, 1, and 2. And if we just want to give one value, for example, where the polynomial takes the value 1, there's a certain artifact of the contour command. You have to put it in twice. So that's why there are 2 1s over here. Let's run that one. And there's the single curve where the polynomial takes the value 1. That doesn't